We now discuss the solution of a problem from the section complex numbers. This question is based on the concepts of complex cube roots of unity. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is, if z square plus z plus 1 is equal to 0, where z belongs to the set of complex numbers, then mod of sigma n is equal to 1 to 15 in brackets z power n plus minus 1 to the power of n into 1 by z power n whole square is equal to. We have z is a complex number satisfying the equation z square plus z plus 1. Then required to find the value of mod of sigma n is equal to 1 to 15 in brackets z power n plus minus 1 to the power of n into 1 by z power n whole square. That is the given question. We now discuss the solution of the problem in detail. We are given z square plus z plus 1 is equal to 0, where z is a complex number. Now take z square plus z plus 1 is equal to 0, multiply throughout by z, then you will get z cube plus z square plus z is equal to 0. Now z square plus z will be minus 1, because z square plus z plus 1 is equal to 0, then z square plus z will be minus 1. Then this equation becomes z cube minus 1. That implies z cube is equal to 1. So if z square plus z plus 1 is equal to 0, z is a complex number, then z is a complex cube root of unity. Z is a complex cube root of unity. And we have studied in our earlier classes the cube roots of unity, and we have one real cube root of unity, that is 1, and the other two are complex cube roots, they are omega and omega square, and we have studied their properties. And in fact, this z what we are talking about here is one of the complex cube roots of unity. Agreed. Now note that z cube is equal to 1, then z to the power of minus 3 is also equal to 1. Multiply throughout by z, then you will get z to the power of minus 2 is equal to z. Yes. Multiply again by z throughout, then you will get z to the power of minus 2 is equal to z square, etc. We continue in the next slide. We have this equation. Now mod of sigma n is equal to 1 to 15 in brackets z power n plus minus 1 to the power of n into 1 by z to the power of n whole square, mod close s. Then now we square it. This is a plus b whole square, a square plus b square plus 2ab. Z power n whole square, that is z power 2n, minus 1 to the power of n into 1 by z to the power of n whole square is 1 by z to the power of 2n, plus 2 into z power n into minus 1 to the power of n into 1 by z to the power of n. Z to the power of n, z to the power of n cancels, you will get plus 2 into minus 1 to the power of n. Thus we get mod of the sum, modulus of the sum is equal to sum of their moduli, that is equal to sigma, that is equal to modulus sigma n is equal to 1 to 15 z to the power of 2n plus modulus sigma n is equal to 1 to 15 z to the power of minus 2n plus 2 times modulus sigma n is equal to 1 to 15 minus 1 to the power of n. Now first we expand the first modulus, first term. So that is equal to, for n is equal to 1, z square for n is equal to 2, z to the power of 4 for n is equal to 3, z to the power of 6. Three terms we group it as one bracket. And then n is equal to 4, 5, 6, the next bracket. N is equal to 13, 14, 15, the last bracket. That is the fifth bracket. The first bracket, second bracket, and the fifth bracket. So also in the case of modulus of sigma n is equal to 1 to 15 z to the power of minus 2n. So three terms we sum it up as one bracket and we get the 5 brackets. That is, first bracket is modulus of z to the power of minus 2, z to the power of minus 4, z to the power of minus 6 for n is equal to 4, 5, 6. The fifth bracket n is equal to 13, 14, 15 plus, and 2 is taken out, and sigma n is equal to 1 to 15 minus 1 to the power of n. When n is odd, minus 1 to the power of n is minus 1. When n is even, minus 1 to the power of n is plus 1. So when n is 1, minus 1. When n is 2, plus 1. When n is 3, minus 1. When n is 4, plus 1. So on and so forth. Up to the first minus 1, plus 1, minus 1, plus 1. Like that, 7 brackets you will get, each bracket consisting of 2 terms, minus 1, plus 1, and for n is equal to 15, minus 1. Now we observe minus 1 plus 1 cancels 0. So like that the first 14 terms will become 0 and you are left with only minus 1. So 2 times of mod of minus 1 is remaining in the third term. Now let's go back. Z square, right? Z to the power of 4 is Z only. Why? Z cube is equal to 1. So Z to the power of 4 is Z only. Z to the power of 6 is 1. Why? Z cube is 1. So Z cube is 1. Z to the power of 6 is 1. Z cube is 1. Z to the power of 4 is Z square. So this is Z square plus Z plus 1. Likewise, Z to the power of 8. Z to the power of 6 is 1. So Z square. Z to the power of 10. Z to the power of 9 is 1. Z. Z to the power of 12. Z to the power of 3. Z cube is 1. So Z to the power of 12 is 1. So each is becoming Z square plus Z plus 1. So each bracket is Z square plus Z plus 1. Z square plus Z plus 1. Similarly, the last bracket. Agreed. Let's go to the next one. Next one, plus mod of this. So Z to the power of minus 2 is Z. Z to the power of minus 4 is Z to the power of minus 1. Z to the power of minus 1 is Z square. Z to the power of minus 6 is 1. So also Z to the power of minus 8, Z to the power of minus 6 is 1. Z to the power of minus 2, Z to the power of minus 2 is Z. Z to the power of minus 10, Z to the power of minus 9 is 1. Z to the power of minus 1, that is Z square. Z to the power of minus 12 is plus 1. Likewise, the last bracket also. So each bracket will have Z plus Z square plus 1, so on and so forth. Plus 2 times, we have already seen that one, modulus of minus 1. Minus 1. Now we have Z square plus Z plus 1 is 0. Each bracket is 0. So also each bracket is 0. So you are left with 2 times mod of minus 1. Mod of minus 1 is plus 1. Therefore, the answer is 2. So the answer to this question is 2. So that is the simple and straightforward question based on the concepts of the complex cube roots of unity from the section complex numbers. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.